Hi everyone. We're doing question 4 of week 6A homework. So I'm gonna be going over this question about how light rays travel through different types of lenses. And so the problem tells us we have an object on the left, and a ray of light is traveling close to and completely parallel to the principal axis. So we need to figure out what happens after it passes through the lens. So first, we will define the main variable we are dealing with here, even though it's a conceptual question. So the main concept and variable here is the focal length, and we write that by a lowercase f. So that's focal length. And so, the focal length is basically the distance from the center of the lens, to the focal point. And so, which is like basically where the light rays either meet up or look like they're spreading out from. And so, since it's a distance, its SI unit is in meters. So, in meters, or we will just write a lowercase m. Now, normally I would show an equation like the thin lens equation and like plug in numbers here, but since this is a purely conceptual question, we don't need any numbers to substitute, and instead we'll have to look at the rules of geometric optics to solve it. So let's break down like what happens step by step. So step one, we will look at a converging lens, which is the lens we have here. And it's shaped like an oval, kind of like, but like kind of sharp at the ends. So by definition, a conversion lens is takes parallel light rays and bends them inwards towards the principal axis over here. And the physics rules tells us that it has to bend and physically pass through the focal point on the far side, which is right here. And you could see it clearly crossing the axis right at the focal point in my sketch. Now, a diverging lens is shaped like an hourglass, and it does the complete opposite. So it bends light rays away from the center axis over here. So when our parallel rays hit this lens, it gets deflected upwards and outwards. So if you follow that bent ray backwards with a dotted line, it will kind of look like it came from the focal point on the left side over here. But the actual real ray of light never touches that point, and it's just like a visual focus. So going back to our multiple choice options, the statement states that the ray passes through a focal point only if the lens is a conversion lens. And so this is completely true, just as we saw that the ray only physically passes through the focal point when it's a convergent lens, as you could see here. And so for a diverging lens, it just kind of glances away and it doesn't touch it. So yeah, that's basically it. And that's why the last option is the correct choice.